Hello everybody. Today we are going to take up the topic set, relation and functions. Let us move on to the first question. The first question is, if A and B are finite sets and A is subset of B, then, so you have four options in front of you. So what the problem tells is A is a subset of B, and we know that if A is a subset of B, A intersection B will be equal to A. So what we have to find out is number of elements in A union B. So I know that number of elements in A union B will be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. And I know that the number of elements in A intersection B and number of elements in A will be same. Therefore, this will be equal to number of elements in B itself. Therefore, the answer is third option, C. So the answer is third option. Okay, let us move on to the second question. The second question is, set A has 3 elements and the set B has 6 elements. Then the minimum number of elements in set A union B is. So the minimum number of elements in A union B is equal to the maximum of number of elements in A and number of elements in B. So we can see that among A and B, B has the maximum number of elements, that is 6 elements. Therefore, the answer is second option, B. So answer is the second option. Okay, let us move on to the third question. The third question is, if g of x is equal to 1 plus root x, g of x is equal to 1 plus root x, and f of g of x is equal to 3 plus 2 root x plus x. I have to find out f of x. Now I know that g of x is equal to 1 plus root x. So I'll replace g of x by 1 plus root x. Since I want to find f of x, I will try to express f of 1 plus root x in terms of 1 plus root x. Can I write this in terms of 1 plus root x? I can write x as root x whole square. This is already 2 root x. I can split 3 as 1 plus 2. Now I can write this part as root x plus 1 whole square plus 2. So I wrote f of 1 plus root x in terms of 1 plus root x. Now I want to know what is f of x. Replace 1 plus root x by x. It will be nothing but x square plus 2. Therefore, the answer is the second option. Let us move on to the fourth question. The domain of the function f of x is equal to square root of x minus 7 by 9 minus x. We know that square root of any function is defined only when this when this number is positive. Otherwise, it will be imaginary number. So what I want here is the domain. That means I want to know for what values of x this is defined. I know that this is defined whenever x minus 7 is greater than or equal to 0 and 9 minus x is greater than 0. That means when x is greater than or equal to 7 and x is less than 9. That means when for all the values of x from 7 up to 9, this function will be defined. So this is the domain of this function. So the answer for this function is the first option, option A. Okay, let us move on to the fifth question. The fifth question is, if A1 is a subset of A2 is a subset of A3 and so on up to A70, and number of elements in AI is equal to I minus 3, then number of elements in intersection I is equal to 10 to 70 of AI is equal to, okay, now when I tell A1 is a subset of A2 is subset of and so on up to subset of A70, I want intersection of I is equal to 10 to 70 of AI, which is nothing but A1 intersection A2, A10 intersection A11 intersection and so on up to A70. Now, I know that each one is subset of the next one. So, if this is A70, the smallest one is A10, because A10 is contained in A11, A11 is contained in A12 and so on. So, the intersection of them will be nothing but A10. Therefore, if I want to know the number of elements in this intersection, it is same as telling I want to know the number of elements in A10. And it's already given there that n of AI is equal to I minus 3. Therefore, n of A10 is equal to 10 minus 3, that is 7. Therefore, the answer is second option, option B. Okay, let us move on to the sixth problem. The sixth problem is the range of the function. The range of the function f of x is equal to, the function is 7 minus x p x minus 3. So, I want to know the range of this function. When I want to find the range of a function, it means I want to find the set of all images. Who are the images here? F of x itself. So, first of all, let me find the values of x for which this function is defined. I know that 7 minus x p x minus 3 is defined only when 7 minus x is greater than or equal to x minus 3 and x minus 3 is greater than or equal to 0. That implies 2x is greater than or equal to 10 and x is greater than or equal to 3. That implies x is greater than or equal to 5 and it's 2x less than or equal to 10 here, because x will be carried to the right. So, x is less than or equal to 5 and x is greater than or equal to 3. So, the values x takes are 3, 4 and 5. So, that means x can take the values 3, 4, 5. So, these are the values in the domain of this function. I want to know the images of these elements. So, that means I want to find the elements of f of x. So, the range of f of x is nothing but set of all images of these elements, that is f of 3, f of 4, f of 5. Now, what is f of 3? It is nothing but 7 minus 3, that is 4p0. F of 4 is nothing but 3p1. F of 5 is nothing but 2p2, which gives me nothing but 1, 2, 3. Which gives me nothing but 1, 2, 3. That means the range of f of x is 1, 2, 3. That is option 3, third option. So, the answer is third option. Okay, let us move on to the seventh question. The seventh question is, if f is mapping from the set R to the set S defined by f of x is equal to sin x minus root 3 cos x plus 1, and if that function is onto, then what is S? We know that if a function is onto, then the range of that function will be equal to the codomain of the function, and the codomain of the function here is S. So S will be nothing but the range. We know that A cos theta plus B sin theta always lies between minus root of A square plus B square and root of A square plus B square. So here we have a function similar to that. We have a sin x minus root 3 cos x plus 1. So this function is in this form, A cos theta plus B sin theta. Therefore this will be lying between root of A square, that is root 3 whole square, that is 3 plus 1 square, plus 1 is added there, and this will be minus root of 3 plus 1 plus 1. So that will be giving me nothing but minus 1 less than or equal to our function, that is sin x minus root 3 cos x plus 1 less than or equal to 3. That means the range of this function f is nothing but the closed interval minus 1 comma 3, which itself will be equal to S, since f is onto. Because if a function is onto, range of that function will be equal to the codomain of the function. Therefore the answer is option 4, that is D, option D. Okay, let us move on to the 8th problem. Let R be an equivalence relation defined on a set containing 6 elements. The minimum number of ordered pairs that R should contain is. Now, what do we mean by an equivalence relation? A relation R is said to be an equivalence relation if it is reflexive, symmetric and transitive. Now, since the set on which the relation is defined has 6 elements in it, let me say the set A on which R is defined is having the elements 1, 2, 3, 4, 5, 6. Since R is reflexive on A, R should have, I know that R is a relation defined on from A to A. Therefore, R is a set of all ordered pairs A comma B, where A belongs to A and B belongs to B. So here, if it has to be reflexive on A, 1, 1 must be present in R, 2, 2 must be present in R, 3, 3 must be present in R, 4, 4 must be present in R, 5, 5 must be present in R, 6, 6 must be present in R. In addition to this, I can add some more pairs, but the minimum is 6, because this 6 must be present. Now, if you observe this relation, what we have written here is satisfying all the 3 properties. That is, it is reflexive, it is symmetric, it is transitive. Therefore, it is an equivalence relation. Therefore, the minimum number of ordered pairs that R should contain to be an equivalence relation is 6. So the answer is third option, 6. Okay, let us move on to the 9th problem. The domain of the function f of x is equal to sin inverse of x minus 3 by root of 9 minus x square. So the function is f of x is equal to sin inverse of x minus 3 by root of 9 minus x square. F of x is defined for what values of x? I know that sin inverse of x should lie between minus pi by 2 and pi by 2. That means x minus 3 must be lying between minus 1 and 1. And that implies if I want to know x lies between what? Add 3 everywhere. So it will become 2 less than or equal to x less than or equal to 4, one of the values of x. Simultaneously, I know that root of 9 minus x square is defined only when 9 minus x square is greater than 0. It cannot be equal to 0 because it is in the denominator. So 9 minus x square should be strictly greater than 0. 9 minus x square is strictly greater than 0 implies x square should be less than 9. X square will be less than 9 only when x lies between minus 3 and 3. X lies between minus 3 and 3. Now let me go to the number line. Let me start from the least, that is minus 3, and the biggest is 4 here. Minus 3 to 3 and 2 to 4. So one of the set of values are here, one of the set of values of x are here. The set of values of x which is common to both, which satisfies both, for which both are defined, is here. That is the interval 2 to 3. So that means the answer for this problem must be third option. Third option is the answer. That is closed interval 2, open interval 3. 3 is not included because we can see here x is strictly less than 3, and when x is equal to 3 denominator becomes 0, therefore 3 cannot be included. Therefore our answer should be option C. Yeah, let us move on to the 10th problem. The 10th problem tells if f of x is equal to 1 plus alpha x, of course alpha not equal to 0, they are telling that this function is the inverse of itself, that is f inverse of x is equal to f of x. F inverse of x is equal to f of x implies what? F of x is equal to x, right? F inverse of x is equal to f of x. Therefore f of x must be equal to x. That implies f of 1 plus alpha x must be equal to x. And what is f of x? It is 1 plus alpha into x. Therefore what is f of 1 plus alpha x? Replace x by 1 plus alpha x. You will be getting 1 plus alpha into 1 plus alpha x. That must be equal to x. Now rather than solving, let us go for verification. So by verification you will find that among the options alpha is equal to minus 1 satisfies this equation. Therefore the answer is the second option. Second option is the answer. Okay, let us move on to the 11th problem. If A and B are any two sets, then A minus B is equal to. So I want to know what is A minus B equal to. I think Venn diagram is the better way to see this. Suppose this is a set A and this is a set B. I know this is the set A minus B. This is the set A intersection B. Suppose I remove A minus B from the set A. What is left? A intersection B. Therefore A minus B is equal to nothing but A intersection B. Therefore the answer is second option. Okay, let us move on to the 12th problem. The 12th problem is if A is equal to set of all x satisfying the quadratic equation x square minus 5x plus 6 is equal to 0. Set B is equal to 2, 4. set C is equal to 4 comma 5. I want to know what is A cross B intersection C. So first of all, let me find what is the set A. So set A will be having those values of x which will be satisfying this equation, and we know that when we solve this equation, the values of x what we get as solutions are 2 and 3. So that means set A has 2 and 3 in it. So find B intersection C. What is common in B and C? 4. Finally, let us move on to find A cross B intersection C. That is nothing but the set 2 comma 3 cross the set 4, which will be giving me nothing but the ordered pairs 2 comma 4 3 comma 4. That is the first option. That is the answer. Okay, let us move on to the 13th problem. The 13th problem is set A has the elements 1, 2, 3, 4 in it. Set B has the elements 1, 2 in it. Then the number of onto functions that can be defined from A to B. Okay, so the number of onto functions defined from A to B will be equal to 2 to the power n minus 2. Of course, where the number of elements in A must be equal to n. So here the number of elements in A is 4 and the number of elements in B must be fixed, that is 2. In that case, this formula will be helpful to find the number of onto functions defined from the set A to the set B. Set A has n elements, set B has 2 elements. Here n is equal to 4. Therefore, here the answer will be 2 to the power 4 minus 2. That is nothing but 14. That is first option is the answer. Okay, let us move on to the 14th problem. 2 functions are defined there. The first function is f is mapping from the set of real numbers to the set of real numbers, and it is defined as f of x is equal to 0 if x is rational and 1 if x is irrational. Similarly, another function g is defined from the set of real numbers to the set of real numbers as minus 1 if x is irrational it's if x is rational, and it is 0 if x is irrational. Okay, now I want to find what is G composite f of E plus f composite G of pi. As you know, G composite f of E will be equal to what? It is G of f of E, and f composite G of pi will be equal to f of G of pi. Now, to find f of E, we must be knowing what kind of number is E. Similarly, to find G of pi, we must be knowing what kind of number is pi. We know that E and pi both are irrational numbers. Therefore, G of f of E, so when x is irrational, what is f of E? F of E is nothing but equal to 1 because E is irrational. So it is 1 plus f of G of pi once again pi is also irrational number, and when x is irrational, what is g of x defined to be? It is defined to be 0. Therefore, g of pi will be 0 because pi is irrational. Now again, what is g of 1 and f of 0? What kind of numbers are 0 and 1? Both are rational numbers. Therefore, g of 1, we know that when x is rational, g of x will be equal to minus 1. Therefore, this will be equal to minus 1 plus. When x is rational, what is f of x? F of x will be 0. Therefore, f of 0 will be 0. So this will give me minus 1. Therefore, the answer is first option. Okay, let us move on to the 15th problem. If A is equal to set 2, 3, 4, 5, which of the following relations is a function from A to itself? So let us see the options one by one. First option tells that f1 is set of all x comma y where y is equal to x plus 1. So what are the ordered pairs that will be present in f1? So those pairs which satisfy this relation will be present in f1. Which are the pairs? Let us begin with x is equal to 2. So when I take x is equal to 2, I will be getting y is equal to 3. When I take x is equal to 3, I will be getting y is equal to 4. When I take x is equal to 4, I will be getting y is equal to 5. But when I take x is equal to 5, I will be getting y is equal to 6. But since I am talking about a relation from A to A, both the elements what we take here in the pair must be present in A. But here, since 6 is not present, it is not a relation from. So I am getting 5 to 6. So this is not a relation from A to B, A to A. Let us move to the second one, that is F2. F2, it's defined as set of all x comma y where x plus y must be greater than 6. So only those pairs which satisfy this inequality will be present in F2. Which are the pairs? So starting with x is equal to 2, when x is 2, what will be y? So x plus y must be greater than 6. So which are the pairs which satisfies that? So it is 2 comma 5, 5 comma 2, both of them satisfy that. Then 3 comma 4, 4 comma 3, then 4 comma 5, 5 comma 4, then 3 comma 5 and 5 comma 3. So these are the ordered pairs which will be present in F2, because all of these are satisfying this inequality x plus y greater than 6. Now I want to see whether this is a function. To be called a relation will be called as a function, or will be said to be a function if every element of the domain has a unique image in the codomain. Now here the uniqueness is not preserved. You can observe that 3 is mapped to 4 as well as 3 is mapped to 5. That means 3 which belongs to the domain has two images, 4 and 5. This is one example here which tells me that this relation F2 is not a function from A to A. Let us move on to the third option, that is F3. So the third option, that is F3, which is nothing but set of all x comma y where x is greater than y. So which are the ordered pairs which satisfies this relation? X must be greater than y. 3 comma 2, 4 comma 3, 5 comma 4, then I can talk about 4 comma 2, then 5 comma 3, 5 comma 2. So these are the pairs we have: 3 comma 2, 4 comma 2, 5 comma 2, then 4 comma 3, then 5 comma 3 and 5 comma 4. Okay. So here also you can observe that one element of the domain, that is 5, has two images. So 5 comma 4 and 5 comma 3 both are present. Therefore the uniqueness is not preserved there. Therefore this relation cannot be a function. Let us move on to the fourth option there. Fourth option tells me that let me call that relation as F4. It is set of all x comma y, where x plus y must be equal to 7. Here, which are the pairs which satisfies that? That is 7. So it is 2 comma 5, 5 comma 2, then 3 comma 4 and 4 comma 3. So these are the only pairs which satisfies that relation, and you can observe that each of the elements, that is 2, 3, 4 and 5, they are having separate images. Therefore this relation is a function from the set A to set A. Therefore the answer is fourth option. Okay, let us move on to the 16th problem. 16th problem is f of x is equal to 2 to the power x minus 2 to the power minus x by 2 to the power x plus 2 to the power minus x. So I want to know what is f inverse of x is equal to how much. So let me call this f of x, f inverse of x. Let me call this f inverse of x as some y. That means I have to find out the values of y. If f inverse of x is equal to y, then x is equal to f of y. So what is f of y? If f of x is defined as this, f of y will be defined as 2 to the power y minus 2 to the power minus y divided by 2 to the power y plus 2 to the power minus y. So let me cross multiply this. So that implies x into 2 to the power y plus 2 to the power minus y is equal to 2 to the power y minus 2 to the power minus y. That is x into, let me write that 2 to the power minus y as 1 by 2 to the power y. This is 2 to the power y minus 1 by 2 to the power y. So this is x into, this is 2 to the power 2y plus 1 by 2 to the power y. This is 2 to the power 2y minus 1 by 2 to the power y. 2 to the power y cancels. So I'll be getting x into 2 to the power 2y plus x is equal to 2 to the power 2y minus 1. That is, I want to know, let me take x into 2 to the power 2y minus 2 to the power 2y, that is equal to minus 1 minus x. So 2 to the power 2y into x minus 1 is equal to minus of 1 plus x. That is 2 to the power 2y is equal to minus of 1 plus x by x minus 1, which can also be written as x plus 1 by 1 minus x. I have just taken the minus to the denominator, so it will become minus x plus 1, 1 minus x. So if I want to know what is the value of y, I have to apply logarithm. So let me apply log function. Log 2 to the power 2y is equal to log of x plus 1 by 1 minus x. So that will be nothing but 2y into log 2 to the base So I should be taking the same base on both the sides. That is, let me take base 2. So it is 1 minus x. So that means y will be nothing but 1 by 2 into log of 1 plus x by 1 minus x. Log 2 to the base 2 will be equal to 1. Therefore, the answer is second option. Okay, let us move on to the 17th problem. In a group of 75%, everyone takes either tea or coffee. If 45 take tea and 35 take coffee, then the number of persons who take tea only is. So I think we can go to the Venn diagram. It's more simple than to going to the formulas of T union C. So suppose I take tea and coffee this way, this will solve the problem. 45 are taking tea, 35 are taking coffee. So we are asked to find how many take tea only. So it's clear that 40 take tea only, because this 5 are taking both tea and coffee. So either we can do it in this way, or we can go to the formula. Number of elements in T union, number of people taking tea or coffee, T union C, is equal to number of people taking tea plus number of people taking coffee minus number of people taking tea and coffee. You can use that formula. That is, or I can go to this formula. I can use this. So anyway, the answer is second option. Okay, let us move on to the 18th problem. The 18th problem tells, let A be equal to set having elements 1, 2, 3. Set B has the elements 3, 7, 9. And the relation which is defined from A to B is set of all ordered pairs x comma y, which satisfies the equation y is equal to 2x plus 1. Now first of all, let me write which are the pairs which are present in R. Thereafter we can tell what is R inverse equal to. So first let me find what is R equal to. So the domain elements are 1, 2, 3. So for each of those, what are the values of y? Then I'll come to know the pairs. So let me take x is equal to 1. What will be y? Y is equal to 3. Let me take x is equal to 2. What will be y? Y will be 5, but that pair cannot belong to R. It belongs to A cross B. We must be knowing that A cross B is set of all the ordered pairs A comma B, where A belongs to A and B belongs to B. So all the ordered pairs will be present in A cross B. But R is a subset of A cross B. At the most, it will become equal to A cross B. Here, if I take x is equal to 2, y will be equal to 5. So 2 comma 5, it's not a pair which is present in R, because they don't satisfy this, because that element 5, though it satisfies this relation, the element 5 is not present in B. So you cannot tell that pair is present in, you cannot tell it's a relation from A to B. So which are the other elements? When I take x is equal to 3, y is equal to 7. So these are the only pairs which are present in R. That means what is R inverse equal to? Just interchange them, you will get R inverse. So therefore the answer is first option. Let us move on to the 19th problem. The 19th problem tells R is a relation defined as R is equal to set of all ordered pairs A comma B, where A and B are integers, which satisfies the relation A square plus B square is equal to 1. Then R is, so I have to check whether it is a satisfying reflexive, symmetric, transitive. properties. First of all, reflexive. For R to be reflexive, I know A comma A must belong to R for all the integers A. So do you think that A square plus A square will give you 1? No. A square plus A square cannot give 1 when A is any integer. It should happen every time. For every integer A belonging to Z, it should happen. It doesn't happen. So R cannot be reflexive. Is it symmetric? Now when I tell A square plus B square is equal to 1, does it imply that B square plus A square also is equal to 1 every time? Yes. You take any two integers. If A square plus B square gives you 1, B square plus A square will also give you 1. That means whenever A is related to B, B is also related to A. Therefore, symmetric property holds good. But what about transitive property? Transitive property tells if A is related to B and B is related to C, A must be related to C. So whenever A is related to B and B is related to C, what happens? A square plus B square must be equal to 1 and B square plus C square must be equal to 1. Does this imply that A square plus C square also must be 1? Not necessary. So this does not imply that A square plus C square is equal to 1. Therefore, R cannot be transitive. Therefore, which is the property R satisfies? Symmetric. So R is symmetric only. That means the answer is second option. Okay, let us move on to the 20th problem. The 20th problem is they have given set A is equal to 1, 2, 3, 4. Set B has the elements A, B, C, D, and the relation defined there is this 1B, 2A, 3C, and 4A. So now I want to check whether this function, is it a function first of all? When do we call a relation to be a function? Every element should have a unique image in the codomain and no element of the domain should be left out. Of course, all the elements are used and each one has a separate image. No element has more than one image. So now let us check whether it is 1, 1 and onto. So this is the domain, this is the codomain. How are they associated? 1 is associated to B, 2 is associated to A, 3 is associated to C, 4 is associated to A. When do we call a function to be 1, 1? If different elements of the domain have different images. But here what you can observe is 2 and 4, which belong to the domain, have the same image. That means F is not 1, 1. Therefore, what kind of function is F? It is called a many one function because more than one element of the domain is associated with one element of the codomain. Therefore, it is a many one function. And is it onto function? No, because one element of the codomain has no preimage. We know that a function F is said to be an onto function if each element of the codomain has at least one preimage present in the domain. But here D has no preimage, therefore it is not onto. And when a function is not onto, it is an into function. Okay, that means the range will be a subset of the codomain. So that means the answer for this function is option D. It is a many one and into function. So option 4, that is D, is the correct answer. Okay, let us move on to the 21st problem. F mapping from the set of real numbers to the set of real numbers is defined by f of x is equal to x square minus 3x plus 7. Now what is f inverse of 5? Okay, so let me call f inverse of 5 as some y. That will imply that f of y is equal to 5. That will imply that, what is f of y? it is y square minus 3y plus 7, that is equal to 5. Therefore, I have y square minus 3y plus 2 is equal to 0, and this will give me two values, that is y is equal to 1 comma 2. That means f inverse of 5 is equal to either 1 and also it's equal to 2. That means there are two images for 5 under the function f inverse. They are 1 and 2. So the answer is second option B. Let us move on to the 22nd question. F of x is equal to x square minus 1. G of x is equal to 2x plus 3. Then I want to know what is f composite, g composite, f of 1 equal to. Okay, f composite g of f of 1. This is how I can write f composite g composite f of 1. It is f composite g of f of 1. Now what is f of 1? F of 1 is nothing but 1 square minus 1. Put x is equal to 1 here. So this will be nothing but f composite g of 0. Okay, what is f composite g of 0? It is f of g of 0. What is g of 0? Put x is equal to 0 here. It is 3. So it is f of 3. Again, what is f of 3? It is 3 square minus 1, that is 8. That means the answer is option A. First option. Okay, let us move on to the 23rd problem. F, which is mapping from the set of real numbers to the set of real numbers, is defined by f of x is equal to 2x plus 3 by 4x plus 5. This is the function, how it's defined. I want to know what is f inverse of x. Similar to the problem what we have seen, where we found f inverse of 5. Let me call f inverse of x as, some y. That means I have to find what is y equal to. Now, if f inverse of x is equal to y, this will imply that x is equal to f of y. So if f of x is defined this way, what is f of y? It is nothing but 2y plus 3 by 4y plus 5. So let me cross multiply. It is x into 4y plus 5 is equal to 2y plus 3. Okay, this, when I simplify, I will be getting y is equal to 3 minus 5x by 4x minus 2. Okay, that means f inverse of x is equal to 3 minus 5x by 4x minus 2, which is the first option, that is option A. Let us move on to the 24th problem. Star be a binary operation on Q. Q is a set of rationals defined as A star B is equal to A plus B minus 1. Now I want to find the identity element under this operation. What kind of element is identity element? An element E is called identity element if it satisfies A star E is equal to E star A is equal to A. Now let me take A star E is equal to A. What is the definition here for A star E? It is A plus E minus 1, that is equal to A. That clearly tells me that E is equal to 1. Even if you check what is E star A equal to A, it gives me the same. E plus A minus 1 is equal to A implies E is equal to 1. That means the identity element is 1. That means the answer is first option. Okay, let us move on to the 25th problem. On the set of real numbers under binary operation star, which is defined as A star B is equal to AB by 3. Of course, A and B are real numbers. The equation x star 3 by 4 is equal to 5. Which is the solution of this equation? I mean, what's the value of x which satisfies this equation? That's the question. Okay, let us use the definition. X star 3 by 4 is defined as x into 3 by 4 divided by 3, that is equal to 5. That means x is equal to 20. Therefore, the answer is fourth option. Okay, let us move on to the 26th problem. On Z, the set of integers, a star b is defined as a square plus b square. Then star is, the option says commutative, associative. Let us check whether it is commutative. Do you think for any two integers a square plus b square is always equal to b square plus a square? Yes. A star b, which is a square plus b square, is always equal to b square plus a square for every a and b. Therefore, I can tell this is true for all a comma b belonging to Z. Therefore, it is commutative. So, star is commutative. Now, is it associative? When do you call an operation associative? A star b star c, if it is equal to a star b star c for all a comma b comma c belonging to Z is our set here. So, if this equation is satisfied, then I call star as associative. But if you verify, suppose I take this a star, what is b star c? B star c is a b square plus c square, that is equal to, again I will be using the operation a star b. It is nothing but a square plus b square plus c square whole square. Whereas a star b star c will give me what? It is a square plus b square here for a star b star c, which gives me nothing but a square plus b square plus c square. You can observe that this is our a star b star c, a star b star c and a star b star c, they will be giving me different values. You can check it by trial and error method by giving some values to a, b, c. You will find that star is not associative here. Therefore, which is our answer here? So, our answer is option C, which tells that it is not associative, because option 1 tells it is commutative and associative. Second option tells it is associative but not commutative. Fourth option tells it is not a binary operation at all. But we know that it is not associative. Therefore, the answer is option C. Let us move on to the 27th problem. If star is the binary operation defined on Z by a star b is equal to a plus b plus 7, then the inverse of minus 7 is. Now, what do we mean by inverse of an element? An element A inverse is called the inverse of an element A if A star A inverse and A inverse star A both gives me identity element E. So, first of all, let me find the identity element. A star E is equal to A implies what? A plus E plus 7 is equal to A. That means identity element is minus 7. So, I got the identity element. So, let me assume let B be the inverse of minus 7. I want to find the inverse of the element minus 7. Let me call B to be the inverse of minus 7. So, minus 7 star B should be giving me E. You know the definition of inverse. A inverse star A and A star A inverse both should be giving me E. So, that is what I am applying. Minus 7 star its inverse should give me identity element. Minus 7 star B gives me what? Minus 7 plus B plus 7, that is equal to minus 7. That tells me that B is equal to minus 7. That means the inverse of minus 7 is minus 7 itself. Therefore, the answer is option D, fourth option. Okay, let us move on to the 28th problem. Given the set A having two elements in it, A, 6, I want to know the number of binary operations that can be defined on A. Okay, let us move on to the solutions. Number of binary operations defined on A, from A to A, I can tell, is equal to nothing but number of elements in A to the power number of elements in A cross A. So better remember this, which is nothing but 2 to the power 4. What is number of elements in A cross A? It is number of elements in A into number of elements in A. It's 4. Therefore, it is 16. Therefore, the answer is second option. So the answer is the second option. Let us move on to the 29th problem. On the set Q of all rational numbers, the operation star, which is both associative and commutative, is given by A star B is equal to. So here we have to check which of the option satisfies both commutative as well as associative property. What do we mean by commutative? Star is said to be commutative if A star B is equal to B star A. Do you think option 1 is it commutative? No. 2A plus 3B. If A star B is equal to 2A plus 3B, what is B star A? It is 2B plus 3A. And we know that they cannot be equal, so it's not commutative. Therefore, that cannot be the answer, because we have to choose the definition which is both commutative as well as associative. Coming to the second option, AB plus 1. It is commutative because A star B is AB plus 1, B star A will be BA plus 1. We know that AB is equal to BA, therefore it is commutative. But if you go to check whether it is associative, that is A star B star C, whether it is equal to A star B star C, it doesn't satisfy that. Therefore, second option cannot be the answer. So coming to the third option tells it is A square plus B square. Just now we have seen A square plus B square does not satisfy associative property, though it is commutative. A square plus B square can be written as B square plus A square. Therefore, it is commutative, but it is not associative. Fourth option satisfies both. You can verify that it is both commutative as well as associative. Therefore, the answer is fourth option. Okay, let us move on to the 30th problem. Let T be the set of all triangles in the Euclidean plane, and let a relation R on T be defined as A related to B if A is congruent to B for all A, B belonging to T. Then R is. Now, the options talks about reflexivity, transitivity, and symmetric. And you know that if a relation satisfies all the three, it is an equivalence relation. Now, coming to congruence. Do you think a triangle is congruent to itself? Yes. Therefore, reflexive property holds good. Do you think if a triangle T1 is congruent to triangle T2, do you think triangle T2 will also be congruent to triangle T1? Yes. So it is symmetric also. And if a triangle T1 is congruent to triangle T2 and triangle T2 is congruent to triangle T3, do you think triangle T1 is congruent to triangle T3? Yes, it is true. Therefore, the relation defined here satisfies all the three. That is, it is reflexive, symmetric, as well as transitive. Therefore, it is an equivalence relation. Therefore, our answer must be option C, equivalence relation. So the answer is option C. Okay, let us move on to the 31st problem. If A and B have three elements in common, then the number of elements common to A cross B and B cross A is. So remember that if A and B have n elements in common, the number of elements that will be common to A cross B and B cross A will be n square. Okay, what I told, A and B have n elements in common. A cross B and B cross A will have n square elements in common. So here what is n? N is 3. A and B are having 3 elements in common. Therefore, A cross B and B cross A will have 3 square, that is 9 elements in common. Therefore, our answer should be option A, that is first option. Okay, let us move on to the 32nd problem. F mapping from R plus to R defined by f of x into y is equal to f of x divided by y, and also they have given that f of 500 is equal to 3. The question is, what is f of 600? Now let me write f of 600 as f of 500 into 6 by 5. I am using 500 because we know f of 500 is equal to 3. And now this is in the form x into y. F of xy is also defined here. Let me use the definition. So according to the definition, this must be f of 500, that is f of x, by y. Y is 6 by 5. F of 500 is given to me, it's 3 by 3, 6 by 5. So this is nothing but 5 by 2. That means the answer must be third option. Let us move on to the 33rd problem. If there are 5040 bijections from A to B, then the number of elements in A cross A. Okay, let me assume that A and B are having the same number of elements, that is n. Okay, I have to find out n. If I come to know n, I can tell how many elements are there in A cross A. We must be knowing that number of bijections from A to A is equal to n factorial, of course, where number of elements in A must be equal to n. And here it's given that n factorial is equal to 5040. That means n must be equal to 7. And I want to know how many elements are there in A cross A. I know it is n of A into n of A, number of elements in A into number of elements in A. That's 49. Therefore, the answer must be fourth option. Okay, let us move on to the 34th problem. You are given two sets A and B. They are defined as given there. A is set of all x, where x belongs to the closed interval 0, pi by 2, and sin x lies between 0 and, in fact, is greater than or equal to 0 and less than or equal to half. And B is set of all x, where x belongs to the closed interval 0, pi by 2 closed interval, and cos x belongs to the closed interval 0, half. Let us see what are the sets A and B in the simplified form. So I know that sin x should be lying between 0 and half. I want to know what are the values of x which satisfies this. So I'll apply sin inverse. If I want to remove sin function, I'll apply sin inverse. Sin inverse of 0 is 0. This is x. Sin inverse of half is pi by 6, sin 30. That tells me that your set A ranges from the values of set A are ranging from 0 to pi by 6. That is 0 to pi by 6. These are the values of A. Similarly, B. Let us move on to set B. Set B, you can observe there cos x. It's given that cos x lies between 0 and half. So the values of x which satisfies this from 0 to pi by 2, which are those? Let us see. Let me apply a cos inverse. Cos inverse of 0. Here I'll apply cos inverse of cos x, and here it's cos inverse of half. I know that cos function is decreasing. Therefore, this will be greater than or equal to. That means cos inverse of 0, we know that it is equal to pi by 2. And this is greater than or equal to x. This is greater than or equal to, what is cos inverse of half? Cos inverse of half is nothing but pi by 3. Cos 60 is half. That means your set B will be equal to nothing but pi by 3 to pi by 2. Pi by 3 to pi by 2. If I take the intersection of A and B, I have nothing in common. You can observe set A is ranging from 0 to 30 degree in terms of degrees if I talk. Same way B is ranging from 60 degree to 90 degree. So there is no angle which is in common in both the set. Therefore A intersection B will be null set. Therefore our answer must be fourth option.
Yes.
Let us move to the 35th problem. In the set Q minus 1 star, where star is defined by A star B is equal to A plus B plus AB. What is 2 inverse star 3 inverse? So to find 2 inverse and 3 inverse, I should be knowing what is the inverse of an element, of any element of that set under this operation. So let me first of all find the identity element. So A star E is equal to A implies what? A plus E plus AE is equal to A. That implies E into 1 plus A is equal to A. 0. That implies E is equal to 0 because A cannot be equal to 1 if A is equal to, A cannot be equal to minus 1 there, because if when I tell E into 1 plus A is equal to 0, either E must be equal to 0 or 1 plus A must be 0. But if I take 1 plus A is 0, A will become equal to minus 1, which is not present in the set. The set, as you observe, is Q minus 1. Q minus 1 is set of all rationals excluding minus 1. Therefore, this cannot be 0. Therefore, E must be 0. Identity element is 0. Let us find what is the inverse of an element. So let me say A inverse is the inverse of A. If that is so, A star A inverse should give me E. So what is the definition? Definition tells A plus A inverse plus AA inverse is equal to E is already got 0. That means our A inverse into 1 plus A is equal to minus A. That means A inverse is equal to minus A by 1 plus A. So I want inverse of 2 and inverse of 3. Okay. 2 inverse will be nothing but minus 2 by 3. 3 inverse will be equal to minus 3 by 4. Now I want the operation, the value of this operation. 2 inverse star 3 inverse is equal to how much? So once again, according to definition, it is 2 inverse plus 3 inverse plus 2 inverse into 3 inverse, which will be giving me nothing but minus 2 by 3 minus 3 by 4. I think yeah, this is minus into minus, this will be once again plus 6 by, okay, yeah, 6 by 12, so it is 1 by 2 there. So if you simplify this, you will be getting minus 11 by 12 as the answer. That is second option. Okay, let us move to the 36th problem. Greatest integer function x is given there. We want to know the domain of that function, and the function given there is, let me call it as f of x, and the function is square root of 4 minus x square by greatest integer function of x plus 2. Now, I know that this function, the square root of a function is defined only when the number under the root is positive. So there are two possibilities. Both the numerator and denominator are positive numbers, or both the numerator and denominator are negative numbers. That means this is defined when 4 minus x square by greatest integer function of x plus 2 is greater than 0, greater than or equal to 0, I can tell. That is, if 4 minus x square is greater than or equal to 0 and greatest integer function of x plus 2 is strictly greater than 0, because denominator cannot be equal to 0, function will not be defined if it is 0. Or another possibility is 4 minus x square is less than or equal to 0, and the denominator, that is greatest integer function of x plus 2, is also strictly less than 0. When both are positive, this will be positive. When both are negative, this quotient will be negative. So what does this imply? That implies x square is less than or equal to 4 and greatest integer function of x is greater than minus 2, or x square is greater than or equal to 4 and greatest integer function of x is less than minus 2. Two possibilities. Okay, x square less than or equal to 4 and greatest integer function of x is greater than minus 2 implies what? It implies, of course, x square is less than or equal to 4 happens when x lies between minus 2 and 2, and greatest integer function of x is greater than minus 2. That happens when x is greater than or equal to minus 1. Okay. Or another case what we have here is x square is greater than or equal to 4. X square will be greater than or equal to 4 when x is greater than or equal to 2, or x is less than or equal to minus 2. In both these cases, you will find that x square will be greater than or equal to 4, and simultaneously greatest integer function of x, if it has to be less than minus 2, your x itself must be less than minus 2. So while incorporating all these cases, I know that here x ranges from minus 2 to 2 and x is greater than or equal to minus 1. So which is the common interval which satisfies both, that is minus 1 to 2. So this implies x belongs to the closed interval minus 1 comma 2, and here this implies that x belongs to minus infinity to minus 2. Therefore our answer must be first option. Okay, let us move to the 37th problem. If n of a is equal to 5, I mean the number of elements in set A is 5. There are 5 elements in A. That the number of reflexive relations that can be defined on A. So we have a formula. Number of reflexive relations. Number of reflexive relations defined on A to A is, the formula is 2 to the power n square minus n. This will give me the number of reflexive relations that can be defined from A to A or on A, which is nothing but 2 to the power 5 square minus 5 here. I mean to say it will be 2 to the power 20 here. So therefore the answer is option C, third option. Yes. Okay, let us move on to the 38th problem. Number of elements in A is 4. Number of elements in B is 6. Then the number of 1-1 functions from A to B. We have a formula. Number of 1-1 functions from A to B is equal to NPM, of course, where number of elements in A is equal to M, number of elements in B is equal to N. So here you can observe that n is 6 and m is 4. Therefore, the answer here must be 6p4. Okay, that comes out to be 360. So the answer is second option. Let us move on to the 39th problem. There's a relation R defined as set of all x comma y, where x and y are natural numbers, and x plus 2y is equal to 10. That is the relation between x and y. Then the number of elements in the power set of R inverse. What do we mean by power set of a given set? Power set of a given set is set of all subsets of the given set. So what is the given set here? The given set is R. Okay, let me find what is R, but I want to find what is the power set of R inverse. Once I know R, I can find what is R inverse. So if you go to find what is R, R is set of all those ordered pairs, okay, x and y, where x and y are natural numbers, satisfying this relation. So put x is equal to, starting with 1, if I put x is equal to 1, I will be getting y is equal to a fraction. But I know that both x and y should be natural numbers, therefore that pair cannot be present in R because it doesn't satisfy that relation. Okay. What about x is equal to? If I put x is equal to, I will be getting y is equal to 4. So 2 comma 4 is a pair present in R. It satisfies all these conditions. Similarly, if you verify, you will find that 4 comma 3 is a pair which satisfies. 6 comma 2 is a pair which satisfies. Finally, 8 comma 1 is a pair which satisfies. These are the only pairs which are present in R. So what is R inverse? R inverse is nothing but 4 2 3 4 2 6 1 8. So how many elements will be there in the power set of R inverse? So number of elements in the power set of R inverse, okay, rather than telling P of, let me say in words, in the power set of R inverse is nothing but 2 to the power, the number of elements in R inverse. The number of elements in R inverse is 4. So that is 16. That means the answer is first option. Let us move on to the 40th question. Let n be the set of natural numbers and the function f defined from n to n as f of n is equal to 2n plus 3. Okay, so the options you can see tells about surjective, injective and bijective. What do we mean by injective? It's nothing but 1 1. What do you mean by surjective? It is onto. Bijective means if a function is both injective and surjective, we call that function to be a bijective function. So injective, I mean 1 1. Do you think this function is 1 1? If it is 1 1 for all numbers n1 and n2 belonging to the domain, if I assume that their images are same, because what I mean by 1 1 is different elements should have different image. So if I assume that the images are same, elements also should come out to be same. Does it happen? 2n1 plus 3 is equal to 2n2 plus 3. That implies n1 is equal to n2. So that means whenever the images are same, the elements are also same. Therefore, this function is 1 1. Okay. So let us check whether this is onto. Now let y belongs to the, of course, codomain be such that it is the image of some element x. Of course, x belongs to the domain. Now what is f of x? it is 2x plus 3, that is equal to y. If that is so, x, of course, as I've written here, x must belong to n, but here what happens is x comes out to be y minus 3 by 2. I know that y is a natural number, and I know that y minus 3 by 2 will not give me a natural number. That means I can find numbers present in the codomain who don't have pre-image present in the domain. So if I can find at least one element in the codomain which does not have a pre-image present in the domain, then the function f is not onto, it's not surjective. Therefore, I cannot tell this function is bijective. Therefore, it is injective only. Therefore, the answer I should be choosing is B, which is injective but not surjective. So the answer is. Let us move on to the 41st problem. Two finite sets have m and n elements. The number of subsets of the first set is 112 more than that of the second set. We know that the number of subsets of a set having m elements is 2 to the power m. Number of subsets of a set having n elements is 2 to the power n. So what is told here is number of subsets of the first set. Number of subsets of the first set is 2 to the power m. That must be 112 more than the number of subsets of the second set. I mean to say, second set has 2 to the power n number of subsets, that plus 112. So these two must be equal. That means 2 to the power m minus 2 to the power n should give me 112. So by verification, you will find that m is equal to 7 and n is equal to, that's the second option, n is equal to 4. If you verify, it will satisfy this equation, that is 2 to the power 7 minus 2 to the power 4 will give you 112. Verify that. So the answer will be second option. Okay, the function given in the 42nd question is minus 5 into plus 6 is equal to 0. If I solve this, I'll be getting two values for greatest integer function of x, that is, it can be 2 or it can be 3. And greatest integer function of x will be equal to if x takes the values from 2 up to some 3, I can tell, open interval 2.2, 2.1 and so on up to 3. Similarly, this means x belongs to 3 up to 4, I can tell. So when I club these two, I'll be getting x belongs to, therefore the answer must be fourth option. Let us move on to the 43rd question. If a set A contains 5 elements and set B contains 6 elements, then the number of 1, 1 and onto mapping from A to B. Okay, set A has how many elements? 5. Set B has 6 elements. That means there are 5 elements in set A. Set A has 5 elements. Set B has some 6 elements. So you can see that A has less number of elements and B has more number of elements. So if you try to find 1, 1 mappings, okay, what about onto? If I go to connect each one, I'll find that you cannot have 1, 1 as well as onto mapping here. It can happen either if both of them are having same number of elements. Okay, so whenever A and B are not having same number of elements, so it depends. So either it will not be 1, 1 or it will not be onto. So you cannot talk about 1, 1 and onto mapping from A to B. Therefore, the number of 1, 1 and onto mapping from A to B must be 0 here. Therefore, the answer is option C. Let us move to the 44th question. Range of f of x is equal to 1 by 1 minus 2 cos x. This is the function given here. I want to find the range. I mean to find the values of f of x. It ranges from where to where. So let me begin with cos x. I know that cos x ranges from minus 1 up to 1. So if I multiply by minus 2, this will become 2. Let us see the solution is greater than or equal to minus 2 cos x is greater than or equal to minus 2, which can be written as minus 2 less than or equal to minus 2 cos x is less than or equal to 2. Now I want, I've already created minus 2 cos x here. I want 1 minus 2 cos x. For that purpose, I'll add 1 everywhere. So it is minus 2 plus 1. Here I'll add 1. Here I'll add 1. So I'll be getting minus 1 is less than or equal to 1 minus 2 cos x is less than or equal to 3. But I want to know 1 by 1 minus 2 cos x lies between which two values. So let me go for the reciprocal, and I know that when I take the reciprocal, the inequality changes. So let me reciprocate. 1 by minus 1 is greater than or equal to 1 by 1 minus 2 cos x is greater than or equal to 1 by 3. And what is 1 by 1 minus 2 cos x? It is nothing but your f of x, same as telling 1 by 3 is less than or equal to f of x is less than or equal to minus 1. That means f of x is greater than or equal to 1 by 3 and less than or equal to minus 1. That means f of x is less than or equal to minus 1 and f of x is greater than or equal to 1 by 3. Therefore, f of x less than or equal to 1 by minus 1 implies f of x belongs to the interval minus infinity minus 1, and this implies f of x belongs to the interval 1 by 3 comma infinity. So that means the answer must be third option C, minus infinity to minus 1 union 1 by 3 infinity. Let us move to the 45th question. Consider the non-empty set consisting of children in a family and a relation R defined as A related to B if A is brother of B. Now, what kind of relation is R? Do you think A is a brother of A? Can a person be a brother of himself? No. That means reflexive property fails there. Do you think if A is a brother of B, B will be brother of A? Not necessary. If A is brother of B, B may be sister of A. Therefore, symmetric property does not hold good here. What about transitive property? If A is brother of B and B is brother of C, do you think A will be brother of C? Yes. That means transitive property holds good here. Therefore, which is our answer here? It is transitive, but it is not symmetric. That is option B. So our answer must be second option. Let us move on to the 46th question. 46th question tells that if f of x is equal to x cube plus 5, then what is f inverse of x? We have seen similar kind of problems previously. Let us call this f inverse x as y. That means I have to find what is y equal to. F inverse of x is equal to y implies f of y is equal to x. What is f of y? It is y cube plus 5 that is equal to x. That means your y cube will be equal to x minus 5. That means your y will be equal to x minus 5 whole to the power 1 by 3. That means f inverse of x is equal to x minus 5 whole to the power 1 by 3. So our answer is in second option. Let us move to the 47th question. Let f mapping from the set 2 comma infinity closed and open to the set of real numbers be the function defined by f of x is equal to x square minus 4x plus 5. Then the range of f is, so I have to find out f of x ranges from between what values. So let me check that. Let me do some simplification here itself. Let me write this as 4 plus 1. That means I have written 5 as 4 plus 1. Therefore, I can write this as x minus 2 whole square plus 1. So what we can observe is x minus 2 whole square is a positive number. It's always positive. Its least value is 0. That implies your f of x is greater than or equal to 1 always. That means your f of x must be ranging from 1 up to infinity. So this must be the answer, option 2. It's option B is our answer. Let us move to the 48th question. So a function f is defined from the set of real numbers to the set of real numbers as f of x is equal to, it's defined as 2x for all the values of x greater than 3. It is defined as x square for all the values of x between 1 and 3 including 3. It is equal to 3x for all x less than or equal to 1. This is the definition. So I want to know what is f of minus 1 plus f of 2 plus f of 4. F of minus 1, where does it come? It comes here. For all x less than or equal to 1, f of x is 3x. That means f of minus 1 must be 3 into minus 1 plus, what is f of 2? 2 is here. It lies between 1 and 3. Therefore, f of 2 must be equal to 2 square plus, what is f of 4? It lies here. For all x greater than 3, f of x is 2x. That means f of 4 must be 2 into 4. That means this is minus 3 plus 4 plus 8. So it must be 9. That means our answer must be option A. Let us go to the 49th problem. I want to know what is G composite F whole inverse. It's better to remember this result. G composite F whole inverse is equal to nothing but F inverse composite G inverse. That means the answer must be option A. Okay, better remember this result. Well, let us move on to the 50th problem. F mapping from R to R defined by f of x is equal to 1 by x for all x belonging to R. Do you think f of x is defined for all x belonging to R? No. In particular, when I take x is equal to 0, f of 0 does not exist. It's not defined. Therefore, I cannot tell f is defined here. Therefore, the answer must be fourth option. Okay, let us move on to the 51st problem. Domain and range of the function f given by f of x is equal to 2 minus mod x minus 5. Okay, let us see the solutions now. So first of all, we know that modulus of x minus 5 is always positive. Okay, domain, of course, is there any value of x for which this function is not defined? No, this function is defined for every real value of x. Therefore, domain will be set of real numbers. But range, let us check the range. As I told, modulus of x minus 5 is always greater than or equal to 0. what about minus of modulus of x minus 5? It will be less than or equal to 0. And what about 2 minus that? So add 2. Add 2. It will be less than or equal to 2. And this function is nothing but f of x. That means f of x is less than or equal to 2. What do I mean by telling f of x is less than or equal to? F of x belongs to the interval, open interval minus infinity and closed interval 2. Therefore, the answer must be second option, option B. Problem number 52. I have a set A which has n number of elements and set B which has 2 elements, that is A and B. Now I want to know the number of surjections. Surjections means onto, number of onto functions that can be defined from A to B. So number of onto functions that can be defined from A to B is equal to, it is nothing but 2 to the power n minus 2, where n is the number of elements of set A, 2 is the number of elements of set B. Okay, where number of elements in A is n, number of elements in B is 2. So this is the formula using which you can find the number of surjections, number of onto functions from A to B. So the answer is second option. Let us move on to the 53rd problem. If a relation R on the set 1 to 3, let me take the set as A, it has 3 numbers 1 to 3, it is defined as R is equal to the set 1 comma 2. So the options are reflexive, transitive, symmetric or none. Let us see. Do you think R is reflexive on A? No. If R has to be reflexive on the set A, R should contain 1 1, 2 2 and 3 3. So it's not reflexive. Is it symmetric? No, because 1 2 is present but 2 1 is not present. So what about a transitive? Is it transitive? Yes, because you cannot prove that it is not transitive. When you cannot prove that it is not transitive, it must be transitive there. Therefore, the answer must be option B, second option. 54th question tells that if A is a set 1 2 3 and it is defined, the relation defined on this set is given as 1 1 2 2 3 3 and 1 2 2 3 and 1 3, then R is, do you think R is reflexive on A? Yes, 1 2 3 are present in A, so 1 1 2 2 3 3 are present in R, so it is reflexive on A. Do you think it is symmetric? No, 1 2 is present but 2 1 is not present. Do you think it is transitive? 1 2 2 3 is there, 1 3 is there. Does it happen that transitivity fails anywhere? No. So it is not symmetric. So which is the answer? That means our answer should be option A. What does option A tell? It tells that it is reflexive but it is not symmetric. That is the suitable answer here. Let us move on to the 55th question. Function given here is f of x is equal to ax plus b, where a and b are integers, and we are given two equations. F of minus 1 is equal to minus 5 and f of 3 is equal to 3. Let us see what this equation gives. F of minus 1 gives me minus a plus b is equal to minus 5, and this gives me 3a plus b is equal to 3. Solve these two equations. You will get A is equal to 2 and B is equal to minus 3. Therefore, the answer must be second option. Let us move on to the 56th problem. Three sets are given there. One is set S, set T and set C. Set S contains set of all points inside the square. So suppose this is a square, all the points inside this is put in the set S, and the set T, set of all points inside the triangle. So let me take a triangle. So all the points inside the triangle are put in the set T. Set C, set of all points inside the circle. Now what is told there is if the triangle and circle intersect each other, so that means circle and triangle are intersecting each other. Suppose this is the triangle, circle, they are intersecting each other and are contained inside the square. They are inside the square. That is how I decided that the triangle and circle are lying inside the square. Then which of the following holds good? Don't you think all the points here are contained inside S? So which is the answer? So let us see the solution. That means the answer must be, don't you think the answer is option C, which tells that the union of S and T and C is nothing but S itself, because T and C are contained inside S. Therefore, when you take the union of them, you'll get back S. Therefore, the answer must be option C. Let us move on to the 57th problem. The domain for which the function defined by f of x is equal to 3x square minus 1 and g of x is equal to 3 plus x are equal. So that means I should equate these two. I should find out for what values of x these two become equal. Just solve this equation, 3x square minus x minus 4 is equal to 0. You will be getting two values for x. They are nothing but minus 1 and 4 by 3. That tells me that the answer must be the first option, that is option A. Okay, let us move on to the 58th problem. A function g of x defined as 1 plus x minus greatest integer function of x. You must be knowing that x minus greatest integer function of x always gives me a fraction. See, suppose I take 2 minus suppose 2. The greatest integer function of 2. In that case, it will be 2 minus 2, it is 0. In other case, if I take any fraction, I will be getting a fraction, whether I take positive or negative. In any case, x minus greatest integer function of x gives me a fraction, which we write it as the decimal part of that. We denote it that way. So this is always greater than 1. This number is always greater, because 1 plus a fractional number should be greater than 1. Now the question is, what is f of g of x? F of g of x. That means I want to find f of a number which is greater than 1. Now what is the definition of f of x? Let us see the definition of f of x. F of x tells that for x is equal to 0, f of x is equal to 0. But for all x greater than 0, f of x is equal to 1. Here I told that it is greater than 1. Surely it is greater than 0. So f of x should be equal to 1. That means the answer must be second option. Okay, let us move on to the 59th problem. F of x is given to be tan inverse of 2x by 1 minus x square. So f is both 1, 1 and onto. That means f is bijective. And if f is bijective, what should be interval? What should be b? Of course, b must be nothing but, we know that if it is bijective, the function is onto already. Let me go for first option, because in the second option, pi by 2 is included. And you know that tan inverse of number, if it's equal to pi by 2, it's not defined. Standards of infinity is equal to pi by 2. Infinity is not defined. Therefore, let us go to the option 1, which says open interval minus pi by 2 to pi by 2. So when I take b is equal to open interval minus pi by 2 to pi by 2, the function defined there becomes bijective. Therefore, the answer is option A. Let us move on to the 60th question. F of x is given to be 3x square minus 5, and g of x is defined as x by x square plus 1. Then g composite f is, so g composite f of x, as we know, is defined as g of f of x. So it is g of, what is f of x? It is 3x square minus 5. Now g of x is defined as x by x square plus 1. So replace x by 3x square minus 5. You will be getting 3x square minus 5 divided by, once again in place of x we have 3x square minus 5, that whole square plus 1. When I expand this and check, I'll be seeing that the answer comes out to be option A, first option. Well, that's it in the topic set, relation and functions. So take care, carry on with your practice, have a happy time. Thank you.